Okay, we'll start, and let me see on my screen. I think you can see the screen, right? Is it visible?
Yes, ma'am, the screen is visible.
Okay, fine. So yeah, so today we will talk about week 5, assignment 5, previous year question paper. I mean, whatever it is given in that previous year assignment paper. So we will talk about that one. Obviously, nuclear and particle physics is the question. So let's start for the question number 1. Uh, in that question, which one of the following reactions corresponds to the reaction gamma plus P goes to N plus pi plus? So this is the question, and there are 4 options. So which one will be the correct one they are asking? So for that question, like obviously we have to check that which one will be the correct option. Like for that case, what we will do? So like here it is saying that gamma is there and proton is there, and the outgoing particle will be neutron and the pi plus. So obviously due to the charge conservation laws, so it will be charge 0, this is 1, this is 0, and this is 1. So that means charge is fine, and obviously if charge is fine, that means maybe the reaction will be possible, and they are also telling that the reaction will be possible. But which following reaction corresponds to this process? So for that case, what we will do, we will simply see, you can see in that 4 options that gamma are constant here. That means obviously the left hand side the gamma particle is as it is there, and for the right hand side the pi plus pi plus pi plus pi plus is as it is there. But only the change is here that P is going to N. So what will happen when P will change to N in that nucleus concept, what will happen, that is the main thing to see, right? So P is going to N. So P is going to N means what? P is what? Okay, in an atom, in a nucleus, let's say it is a nucleus, and inside the nucleus, proton and neutron are accumulating in that nucleus only. So let's say in that XZA, this is the XZA component, and there is proton and neutron present in such a way that it is given here. But it is converting into a neutron. I mean, Y. Y or something which is X changes to Y. Right? So X changes to Y means what? Proton will be converted to neutron. That means, let's say in our this component XZA. XZA means Z number of protons are there and A minus Z number of neutrons are there in this case. Right? So when proton will be converted to neutron, one proton will converted to neutron. That means one proton will be less. So the new particle, what will I can write it as Y, that will have Z value, I mean proton number as Z minus 1, because it has one proton is changing to neutron. So the proton number for Y value will be Z minus 1. Okay, and one, I mean proton is changing to neutron. That means whatever the neutron was there, one neutron should be added in that case. So the neutron will be A minus Z. That was previous neutron, but right now for Y case, neutron will be A minus Z plus 1, because one proton is converted into neutron. That means for Y, the final nucleus, one proton will be less, but one neutron will be greater. So now you can see, if I write here the Y as a final one, final particle, for this case, proton number will be Z minus 1, because one proton is converted to neutron, but the neutron number will be increased by 1. That means A minus Z plus 1. This one was the previous neutron plus 1. Okay. So that means our Y final particle has Z value Z minus 1 and N value A minus Z plus 1. Now we have to calculate quickly that P plus N is nothing but the total number. So P plus N will be how much? A minus Z plus 1. So you can see plus 1 minus 1 will cancel out, minus Z plus Z will cancel out, only simply A will be there. That means our y, whatever the final particle will be, that will have proton as z minus 1, but total atomic number will be exactly same whatever it was previously, a. Okay, so our x z a plus gamma, which is coming as something plus 5 plus, that will be x z minus 1, but still it will be a. Why? Because z minus 1 means 1 proton is less, but 1 neutron is also getting increased, so that means 1 proton is converted to 1 neutron, so that it is coming like xza going to xz minus 1 a, and then a gamma and pi plus is there. So for this case, what was happening? For this case, the proton number is z minus 1, neutron number is a minus z plus 1. For this case, proton is z, neutron is a minus z. Now you can see clearly that one is z minus 1, it is getting z minus 1, but here it is getting a minus z plus 1. Okay, so the answer will be xza plus gamma going to xz minus 1a plus 5 plus. So let me check the correct answer. Z minus 1 a plus 5 plus, that means the option number a will be the correct one. Okay, so this is the first question. So now we can go to the next question. So which of the following reactions corresponds to the reaction gamma plus n going to p plus 5 minus? Obviously that is a very simple, very similar to the first one. If someone has a joint later, so if someone missed the first question, then we can see the second question elaborately. Can someone mute yourself? Okay, fine. Okay, so here it is very similar to the first one. So if you miss the first one question, then we can discuss the second one, then you can understand the first one as well. So here they are asking that gamma plus n going to p plus 5 minus, in this process, what will be corresponding to this process, A, B, C or D. So what is this? This is nothing but, first of all we are checking the charge. Charge is fine, that means this is 0, this is 0, this is plus 1, this is minus 1. So obviously charge is fine, no problem. Now you can see that options, gammas are there in the left hand side, pi minus is there in the right hand side. So that means obviously we have to check that which notation corresponds to n going to p. That's it. Okay. So n going to p. N going to p means whatever the, let's say in the parent, I mean this x z a, whatever, how much value of z was there and how much value of a minus z was there, one neutron will be less and one proton will be added in that final state. That means in that initial state, if x z a was there, that means our proton number is z, neutron number is a minus z. That we all know. Okay. So that was for initial particle. That means xza. Xza means proton is z and the neutron is a minus z. But here they are telling that one of the neutron, that means one of the a minus z neutron will be converted to a proton. Okay. So it means one neutron will be small, one neutron will be less, but one proton will be greater for the final case. For the final case, our proton should be z plus 1 because one neutron gets converted to one proton. But the neutron number should be decreased by 1 because in the initial state, whatever the number of a neutron was there, one neutron was converted to proton. That means one in the final state one neutron will be less, one proton will be greater. That's it. So the final state particle, this should be like proton will be Z plus 1 and neutron will be A minus Z minus 1. Now coming to the notation. In that notation ZA, there was nothing but the number of proton it is given and total number, that means proton plus neutron is given. Right, because that XZA means the proton number is Z and the total number B plus N is A. So if I calculate the value of N, then obviously I want to calculate A minus Z, because B is Z, so obviously A minus Z. Similarly, as I already got to know that in the final state what will be the proton and neutron, then I can write here the final particle will have proton as Z plus 1, because you can see here one proton is added, and a neutron will be A minus Z minus 1. So, neutron number will be A minus Z minus 1. But in that notation we have to calculate P plus N. So let me write here P plus N. So P plus N will be how much? Z plus 1 plus A minus Z minus 1. So you can see Z minus 1 plus 1 will cancel out. So obviously 1A will come. So the final particle will have notation as proton number as Z plus 1, but the atomic number will be simply A. So the notation X Z A plus gamma going to pi minus plus X Z plus 1 A. Why? Because one neutron is converted to proton. Here one proton is added, no neutron is minus. I mean one neutron will be less and one proton will be added. So here you can see the proton is as already added, but one neutron will be minus, because for this case the neutron number is A minus Z minus 1. So that was previous neutron, but right now it is one number less. So the final answer will be X Z plus 1 A. So let me check the option X Z plus 1 A. That means the option number B. If you have any question, if you have any doubt, then you can ask me, so we can discuss that one also. So first two questions are very similar to each other. So if you know the first question, then you can obviously answer the second question. Just simply we just need to check that if from which to which it is changing. Here the proton is changing to neutron. That means one neutron will be added and one proton will be subtracted. And here the neutron is converted to proton. That means one proton will be added and one neutron will be subtracted. Okay, so maybe we can go to the next question. Question number 3. Germanium 3260 beta plus decays to gallium 3160. If their atomic masses are this and this respectively, what is the Q value of the reaction in MeV units? So as we have already told these things so many times that how to calculate the Q value, and if it is in the atomic mass also, then what will be the expression for the Q value. So we can simply write the expression right now, or otherwise if you want to know how this expression is coming, then I can also describe that one right now. But let me write here first. Germanium 3260 goes to gallium 3160 plus beta plus, right? So in that case, beta plus means what? Beta plus means obviously there is a E plus. Okay? Okay, fine. So here they are asking that Q value. What will be the value of Q? So Q value in terms of the atomic masses they have given. So in terms of atomic masses, if I want to write, the Q will be atomic mass for germanium. Let's say I'm writing here AT means atomic mass, minus atomic mass of gallium. Then there will be a minus 2 into Me, the mass of 2 times the mass of electron. So how it is coming? That is nothing but germanium nuclear mass minus gallium nuclear mass. This is the actual one, okay? So germanium nuclear mass, gallium nuclear mass, and there will be a Me obviously. So this is the case. So Q value is what? Q value is nothing but the nuclear mass of the initial particle minus the nuclear mass of the final particles. So this is the actual relation. But if I want to convert that atomic nuclear mass to atomic mass, so that will be simply Ge atomic. Let me clear that one because we are talking right now in terms of atomic mass, so it's better to write here only atomic mass. So this will be atomic mass of germanium minus atomic mass of gallium minus 2 into Me. So let's calculate that one. So atomic mass is given here 59.97, 019 U, and gallium atomic is 59.95706. And Me mass is like 0.511 MeV. Why I am writing here in MeV unit? Because they are asking that the value of the Q should be in MeV unit. So as it is in AMU unit, so we have to convert that one. So AMEU is 931.5 MeV. Okay. So we can just write that one simply. So Q value should be like this one minus 2 into this one. I mean, like obviously it should be converted into AMU. So what we will do, we will simply calculate like 59.97019 minus 59.95706. This is a whole in U unit, right? But AMU into, I mean, that should be multiplied by 931.5 to get it in MEV, minus 2 into 0.511. It is also in MEV, right? So as a whole, all the things are in MEV. So this is the equation. So maybe let me calculate that one. If you want to know that how this minus 2 Me is coming out, then I can also tell, but right now I think it's already explained in the last class, so maybe we can skip that one right now. But if you have any doubt, obviously you can ask me so that I can tell. 59.95706 into 931.5 minus 2 into 0.511. Okay, so this is 11.208 MeV, like that. So let me come into the so here the answer was 11.208, so obviously I can write it like 11.21 MeV. So the option will be option number B. If it is a beta plus decay, then only there will be a minus 2 Me term in the atomic mass term, I mean like in atomic mass unit. But if it is a beta minus decay, then there will be simply parent atomic minus daughter atomic. Why? Because like obviously we can just see that one, then we can understand that how it is coming. So there will be no any term, only simply it will be minus, that's it. So parent atomic minus daughter atomic for beta minus decay Q value, but for beta plus decay Q value, obviously it will be parent atomic minus daughter atomic minus 2 into M into Me. 2 into Me. Okay. So the 2Me should be subtracted. That we have to take care for the atomic mass case. If it is given in atomic mass unit. If it is given in the nuclear mass case, then obviously we need to take care about all these things. That simply the subtraction of the daughter and particle, parent particle minus daughter particle. Okay. So in the beta decay, okay, one more thing, if it is written as in the beta decay means obviously it will be a beta minus decay. And also you can check from that Z value also, if it is beta decay or beta plus decay. If it is beta plus decay, that means it will be explicitly written by beta plus decay. If it is simply a beta minus decay, then sometimes it will be written in beta minus decay or it will be written in beta decay. Okay. So in the beta decay, if it is written in beta decay, that means it will be a beta minus decay. And obviously you can see from the expressions also, HF 72 is going to TA 73. So if 73 is there, that means obviously minus 1 0. Okay. So it is a beta minus decay. Okay, fine. So in the beta decay of these to this, to find the maximum kinetic energy of the electrons emitted in emitted. Obviously the final maximum kinetic energy of the electron emitted is nothing but the Q value of this reaction. Okay? And it is given that the atomic masses of HF and TA are given by this and this. So they are given it is in the unit of AMU, atomic mass unit, and they are asking us to calculate the value of Q. Okay, so the value of Q they are asking. So obviously, and it is given in atomic mass case. So as it is a beta minus decay, so for beta minus decay, the Q value will be like HF atomic minus TA atomic. That's it. There will be no minus 2Me or something. It is in terms of atomic unit, atomic mass. If it will be a nuclear mass, then HF nuclear mass minus TA nuclear mass minus M into M will be there. But if it is an atomic mass, then obviously there will be no 2E and only simple Me like that. Okay, so this is the Q. For HF80 is given as 181.950554. U. Now TA atomic is what? 181.9501518. 9501518. 9501518. Okay. So they are asking the Q value in terms of MeV. So what we will do, we will just simply subtract this one from that one, minus 185.9501518. That will be in U unit, but you have to multiply that one by 931.5 to make it in MeV unit. So let's calculate that one. 181.950554 minus 181.9501518. This one into 931.5. Okay. So the answer is 4.022 into 10 to the power minus 4 into 931.5 MeV. So this will be equal to 0.37 MeV. Okay, actually the answer was like 0.3746493 MeV, but we can just simplify, write it like 0.375 MeV. So the option A is correct. So I'm again telling that for beta minus decay in terms of atomic mass it will be simply the q value will be simply the difference between the atomic mass of parent particle and the daughter particle. But for beta plus case, in terms of atomic mass, the answer will be for the q value calculation, it will be parent particle atomic mass minus daughter particle atomic mass minus 2 into electron mass. Okay. And in terms of nuclear mass will be q value should be equals to the nuclear mass of parent particle minus nuclear mass of daughter particle plus me. That's it. Okay. Yes. So I think up to question number 4 there is no problem. I think I'm audible. Okay. So as there is no question up to question number 5, then we can go to the question number, after question number 4, then we can go to the question number 5. If you have any doubt regarding question, 1, 2, 3, 4, then obviously you can ask me. Because we are telling that right now this as question number 5 is a little bit different from the other 4 questions, so that's why I am telling that. If you don't have any doubt regarding 1, 2, 3, 4, question number 1 was nothing but P to N or N to P, question number 1 and 2. Question number 3 was Q value calculation, question number 4 was also the Q value calculation. Now coming to question number 5. Okay, so there is no problem after question number 4. So coming to question number 5. This question is a little bit big. Okay, just we have to check a little bit carefully. The differential cross section of a reaction is found to be d sigma d omega equals to a into 1 plus cos theta. In a specific experiment to study this reaction, the projectile beam prepared with the flux density 10 to the power 25 particles per centimeter square per second was sent to a fixed target. A cylindrical detector is placed with its axis along the axis of the beam on the opposite side. The detector D1 spans an angle 15 degree with the target as the center. It detected 432 particles in 30 seconds. When it is replaced by another detector D2 spanning 30 degree, how many particles will it detect in 30 seconds? This is the question. So let me break the question in different phrases so that we can understand that one very clearly. Okay. The differential cross section of a reaction is given. Okay. Differential cross section of a reaction is given in terms of theta, d sigma d omega. Whatever it is given here, at the very first I am going to write d sigma d omega is equals to a into 1 plus cos theta. Okay, it is given. In a specific experiment to study this reaction, whatever the differential cross section of the reaction is given, this reaction we want to study in a specific experiment. So for that, what we will do, the projectile beam prepared with the flux density 10 to the power 25 particles per centimeter square per second, and it was sent to a fixed target. So experimentally what is happening here, pictorially if I want to write, let's say there is a fixed target. This is a fixed target. Why I am writing here only a simple circle? This is a fixed one. So it is not going to move anymore. So this is a fixed target, right? Now a beam of particles are bombarding. They are coming here to hit the target. Okay, very good. So there are so many numbers of particles coming, and the number is also given here. The number is like 10 to the power 25 particles per centimeter square per second. So this is the flux. This is the flux. Let me write here flux. flux is 10 to the power 25 particles per semi-square per second. So what does this mean? This means that in 1 second, in 1 centimeter square area, 10 to the power 25 particles will be coming from that source, and it will bombard the target, fixed target. Okay? Okay, very good. So this is the case that one fixed target is there and the particles are coming here, and it will hit the target, and after that it will be detected. So after hitting, let's say the particles are coming out. Obviously the particle will come in every direction. It can come in every direction because due to the energy and momentum conservation law, it can come in any direction. So now they are telling that a cylindrical detector is placed with its axis along the axis of the beam on the opposite side. So one detector is placed. Where the detector is placed? Detector is placed in the opposite direction. I mean, this side is the flux one, particle flux, and this side the detector will be there. Obviously, if I want to detect any particle from the target which are coming out, obviously we have to place one detector here only, not here. So there I want to place a detector, but how the detector is placing, that they are telling. A cylindrical detector is placed with its axis along the axis of the beam on the opposite side. The detector D1, let's say the detector name is D1, it spans an angle 15 degree with the target as the center. So what does this mean? This means that let's say this is the center axis, right? So from center axis, a 15 degree angle, there will be a detector. This is the detector. It is placing at the 15 degree angle from the main axis. Okay? This is D1. So in 30 seconds, this is the D1, and obviously if it is a detector, it will collect some particles. It will detect some particle which is coming out. And it detected 432 particles in 30 seconds. So D1, let me write here, D1 detect 432 particles in 30 seconds. Okay? So that is the case. D1 detect 432 particles in 30 seconds. And D1 has an angle 15 degree with the axis of with the main axis of the incoming particle beam. It is given, right? Now they are asking that how many particles would it detect in 30 seconds for D2 if it is spanning 30 degree. That means another detector, let's say it is placing here, which is at an angle of 30 degree, and it is named as 32. So how many number of particles will be detected by D2 in 30 seconds? This is the question for this case. They want to know how many number of particles will be detected by D2 at 30 seconds. And they have already given that 432 particles has already detected. 432 particles will be detected by D1 in 30 seconds. So what will be the number of the particles detected by D2? Okay. So this is the question. Now let me answer the question. So how to answer the question? As I told you, this is the fixed target. This is the beam coming, and let's say here one D1 is present, and this is at 15 degree angle. Okay. So as they are asking the number of particles which will be detected by the detector. So number of particles which will be detected by the detector, that will depend on some parameter. And what are the parameters that we have to know? If we got to know how to calculate the number of the particles detected by the detector and what are the factors for these calculations, then we can obviously know the answer. So let's say number of the particles at D1. Let's say I'm talking about the number of particles detected at D1 at the very first. So it is proportional to which terms? The number of the particles should be detected in the detector D1. It should be proportional to the number of the, it should be proportional to the flux. Why? If the number, flux means what? Flux means the number of particles coming from the source and it is hitting the target. So obviously if the number of particles, more number of particles will be hitting, then obviously the more number of particles will be interacting with the target and the more number of particles will be detected to the detector. So the number of the particle is directly proportional to the flux of the beam, incoming beam. This is the first one, and this is also proportional to the cross section. Cross section means what is the how much area is applicable to interact. So obviously if the area of interaction is more, then the interaction will be more, and if interaction will be more, that means the detected particles would be more. So it is directly linked to the number of differential cross section or simply the cross section it will be directly proportional. It will directly also proportional to the time. How much time we are taking, with the, let's say at the very first it was telling that 30 seconds. If we will take the detector for 1 minute. So obviously the number of particles detected by the detector T1 will be greater. So the number of particles detected by the detector will be directly proportional to delta T as well. Okay. So these three are the main one. So if I want to write here in D1, that can be written as like delta T into flux, okay, into sigma. Sigma is like total cross section. But here in that question they are given it as differential cross section. So for that case what we need to do? D sigma d omega into d omega. Otherwise we need to know the total cross section, but they are giving us as differential cross section. So we have to integrate that one to get the total cross section, right? So d sigma d omega into d omega, integration over all the angle, then we can get the value of total cross section. So delta T flux, and then there will be number of particles per unit volume, the number density. Number density can also be there. I can write it like here also, number density. So that is fine, no problem. And then d sigma to d omega into d omega. Now d omega. Let's talk about d omega. It is already given. This is already given. This is already given. This is 10 to the power 25 particles. This is 30 second. And we will not right now talk about that one because it is not necessary here. This is also given here that 1 plus cos theta. So all the terms are given, but only d omega is unknown for us. So we need to check what is d omega and how, what will be the integration factor here. Okay? So d omega. D omega is what? D omega is nothing but solid angle. Right? So solid angle is what? Solid angle is if I write here simple omega, that can be written as like area divided by r square. That is the solid angle. Okay? So for d omega, that will be simply dA divided by r square. D omega is nothing but a very small portion of the total solid angle. So obviously d omega is dA by r square. Now what is dA? If it is a cylindrical case, if it is a cylindrical, and actually it will be a spherical why it is a spherical case? Because you can see the outgoing particle can go in any direction from 0 to 360, right? So it is a spherical case you can think about. And if it is a spherical one, then for the spherical one, what will be the value of SKA, the area that we have to need to know, and after that we have to just divide that one by r square to get the value of d omega. So what is dA here? dA is nothing but r dr r d theta, then sine theta, actually r d theta, r d theta, r d phi, sine theta. This is d omega. So what does this mean? This is r square sine theta d theta d phi. This is the expression for dA in a spherical polar coordinate like thing. So if I want to write here d omega is what? Simply dA by r square. That means it is sine theta d theta d phi. Okay? So sine theta d omega, I got to know that it is sine theta d theta d phi. Now we just need to write here n d1 is equals to f delta t n. These all will not be that much problematic in our calculation, but okay, fine. Now there will be, as d theta d phi is there, so obviously two integration should be there. Then d sigma d omega sine theta d theta d phi. Okay. So now if I want to write here f delta t n. Okay, now you can see here obviously the integration on theta as well as phi. So for integration in this case as d1, it will be 0 to 15 degree, because in that case we saw that here there was a fixed target and the target the detector was at the 15 degree angle. So theta will be from 0 to 15 degree. But what about the phi? Phi will be simply 0 to 2 pi. This is the azimuthal angle. So this is the azimuthal angle, and azimuthal angle should be covered fully. So 0 to 2 pi. That's it. So now if I want to write here a 1 plus cos theta sine theta d theta d phi integration theta is from 0 to 15, phi is from 0 to 2 pi. Now you can see here number 6 has come. Okay, fine. D phi integration is simply independent one, so d phi will come out as whatever it is. So f delta t n, then d phi will come out simply as 2 pi, because phi and phi will be from 0 to 2 pi, it will be 2 pi. So the integration will be mainly a will be coming out because it is a constant simple. So 1 plus cos theta sine theta d theta, and theta will go from 0 to 15. Okay, so this is the case. So why I am writing here nd1? nd1 we already know that the value of nd1 is 432. But to know the value of nd2, we need to calculate the value of nd1 relation. Otherwise, we can't know. Okay. Why I am telling that one? See here. Maybe I can write in the upper page. I can write here. What we were left, nd2, the number of particles at d1 detector, that is equals to f delta t n 2 pi, then integration 1 plus there will be a 1 plus sine theta cos theta 1 plus cos theta sine theta d theta. Theta equals to 0 to 15 degree. Okay. So if delta t n 2 pi a, these all are coming as a constant value. Then sin theta integration. Sin theta integration is minus cos theta. 0 to 15 plus sin theta cos theta. So half, if I take out, then sin theta cos theta is half. 2 sin theta cos theta is sin 2 theta. So the integration will be minus cos 2 theta divided by 2, 0 to 15. Okay, I hope it's fine for everyone. Now let me write here all this thing as a prime because it's a simple constant value. So a prime. Then minus cos 15 plus cos 0 is 1 plus 1 by 4. Now why 1 by 4? Because it is 1 by 2 and 1 by 2. 1 by 4 minus cos 30 degree plus 1. Yes, because cos 0. So this is a prime minus cos 15 minus cos 30 by 4. Then you can see here plus 1 plus 1 by 4. That means plus 5 by 4. Right? Okay. I am doing little bit step jump. If you did not understand that one, obviously you can tell me. I can break it in a line by line. So that is what? That is A432. Very good. Now coming to ND2, that we want to know. So why we are doing this one? Because from this we can got to know what will be the value of A prime. Because in A prime all the things are not given here. So A prime is simply a constant. So we have to know the value of the A prime. So A prime is 432 divided by these things. So for ND2 also A prime will be there. Why A prime will be there? Because in that A prime there is nothing which depends on D1 or D2. This is simply flux, delta T, and delta T is also the same. It is saying that the 32nd. Now N, then A, then 2 pi. All these things are same for D1 as well as for D2. So all the things we can write it as A prime. Now here 1 plus cos theta sin theta d theta. Theta is from 0 to 30 degree because for D2 it's already given in the question that for D2 we are talking about the spanning of 30 degree. So for this case only the difference is here, that previously it was 15 degree, right now it is 30 degree. So I am writing here A prime. Now simply minus cos theta 0 to 30 plus 1 by 4 minus cos 2 theta 0 to 30. I can write it directly from here also because you can see. Oh, actually there will be. It's fine. Okay. So A prime we can write simply this one divided by minus cos 15 plus 5 by 4 minus 1 by 4 cos 30, whatever it was there, right? Then minus cos 30 plus 1 plus 1 by 4 minus 1 by 4 cos 60. So this whole we need to calculate. Then we can got to know what will be the value of ND2. Okay, so cos 30. Maybe you can calculate that one also, but yeah, fine. I'm just going to calculate for your case. Cos 15. Cos 15 into minus 1 plus 5 divided by 4 minus 1 divided by 4 into cos 30. This is 0.0675, like that. And how much is this? This is minus cos 30 plus 1 plus 1 divided by 4 minus 1 divided by 4 into cos 60. This is 0.25897. This into 432 divided by, so this is 111.877 divided by 0.0675. That divided by 0.0675. So it is like 1657.43, like that. So this is the answer. Now come to the options. It is nearly 1657, 1656, 1657. Why it is exactly not matching? Because obviously there is some factors I just multiplied and calculated. So it's nearly 1656 or 1657. So the answer will be this one. Does anyone have any doubt on this question? Because it's a little bit long question. So if you have any doubt, you can ask me. I think I am audible. I am audible, right? Can anyone confirm I am audible or not?
Yes, ma'am, you're audible.
Okay, fine. So,
Yes,
yeah. So, you understand the question and as well as answer, right? So, if you have any doubt, you can ask me. But it's a very simple question. That in that question they are asking what will be the number of the particle detected by the detector, and the expression will be simply delta t into f into n. Then there will be a differential cross section and d omega. So how to calculate d omega, that also I told you. Then after that we put that expression in that nd1 expression. Then we calculate the total value, and we just use the number of the d1 because we don't know about all the terms it is given here. And also you can see here one a is given and a is unknown. A is simply a constant. I don't know about the value of a. So we can't calculate nd2 directly. We have to calculate in terms of nd1, and after that we got to know the value of a prime, all the terms in front of the integration. Then only we will put that value to nd1, nd2, and we can calculate the value of nd2. That's it. So we just calculated that one. Actually, due to the space constant, I just calculated here, and then you just see that value, and the value is 1657.43 or 1656, like that. So this is the case. Now maybe we can go to the next question. Next question is very, in the extension of the first one, in the above question, you can see this is the extension of the first one, previous one. How many particles would be detected by D1 when the flux density is doubled? This is in the continuation of the first above question, so that's why they told us that ND1 detect 432 particles previously, right? Now they are telling that what will be the particle number would be detected by D1 when the flux density is doubled. I told you that ND1 is simply proportional to flux. It is simply proportional to delta T, that means the time. It is simply proportional to number density. It is simply proportional to d sigma d omega. D omega. Or sigma only. So as we can see from these expressions, they told that now the flux is doubled. That means f prime is right now 2f. So obviously in d1 prime, as it is f prime, and it will be simply 2f. So whatever the number was there in d1, the nd1 prime will be 2 into nd1, as it is doubled, and the interaction relation for nd1 prime and f prime is simply a linear dependence. So if f prime will be double, then obviously nd1 prime will be double. So as it was 432, so the value will be 468, 864. So the answer will be C. If they will ask me the question that in that our question how many particle would be detected by D1 when the time increased to 60 seconds, the same answer will be there, because for that case also previously it was 30 seconds, now it is 60 seconds, and delta t is linearly proportional to nd1. So as it was 432 previously, right now at 60 seconds with flux as f only, the value of nd1 prime will be 864, which is 2 into 432. Okay. I think you understand the question as well as answer. So, okay, so maybe we can go to the next question, and next question is this one. This one is also a little bit different from the previous one. So, up to this, if you have any doubt, you can ask me, or otherwise, we can go to the next question. I think there is no problem till now. If it is little bit quick, then also you can tell me. If it is little bit slow for you, then also you can tell me, and I can do it little bit first. But obviously, whatever is your convenient, you can tell me. I can do accordingly. Okay. Okay. So this is the question number 7. No, 7. 7, because there is a simple question. So question number 7. Which of the following statements are correct? There are 3 statements given. In compound reaction, an intermediate nuclear state is formed, which decay to the final products. In direct reactions, only a few nuclei in the periphery surface are involved. Nuclear reactions in which only the nucleons at the periphery take part are called compound reactions. So these are the 3 options. I think Professor Paulus Paulus has already told you about the different types of nuclear reactions, like compound reaction, what is compound reaction, what is direct nuclear reaction. Like in the direct reaction also we can see there are so many classifications, like pick up, then break up, then there will be a knockout, then there will be elastic scattering, all these things are there. And what is compound reaction, that is little bit different with the direct reaction. So all the things maybe Professor Paulus has already told you. So based on this concept, I just want to answer the question, whatever it is given here. So as he has already mentioned what is compound, what is direct, but still in this question we need to know a basic concept about compound and direct reaction. I just want to tell you a little bit more on compound and direct reaction, and after that we can answer the question. So in what is there in compound reaction, what is there in direct reaction, what are the differences between these two? I mean main differences. Obviously there are so many differences, but what are the main differences between these two? So what is compound reaction actually? Let me write here A plus B goes to C plus D. This is simply a nuclear reaction expression, right? A can be anything, B can be anything, C can be anything, D can be anything. So basically in most of the cases one will be projectile and one will be target. Like projectile will come and it will hit the target, and as an outgoing particle C and D will produce. That is the thing. In most of the cases, not obviously in all the cases that is the ultimate one, but most of the cases it is like that. Like one neutron or proton or gamma is coming, and one fixed target or let's say heavy target is there, and it will hit that one, and after that it will make something new. This is for direct as well as compound nucleus. But the difference between compound nucleus and direct reaction is that in the case of direct reaction, A and B, I mean whatever it is given here, A and B, the initial particles, they are interacting for a very short time. What does this mean? This means that the interaction time between A and B will be very small, so that it will not interact internally. When it will be possible? It will be possible only if among A and B, one of the particle is high energetic. Why I am writing it as high energetic? Because let's say our projectile N or P or gamma, whatever, this is very high energetic. So it will just come, it will simply directly interact only on the surface of the particle B, and it will just make some new particle. That's it. So this means in the direct reaction, the interaction time between A and B are very small due to one of the particles high energy. If it is very much high energetic, it will not see it will not move it here and there. It will just simply come, and it will quickly interact with the particle B, and it will simply produce a new particle C as well as D. So in the direct reaction, the main property is that interaction time is very small. Now coming to the option it is given here about the direct reaction, because we are right now talking about direct reaction. So whatever the direct reaction expression statement is there, we have to check that is correct or not. In direct reactions, only a few nuclei in the periphery are involved. As I already told you that A will not interact that much internally with B, so obviously it will interact only on the surface of the particle, only on the surface of the nuclei B, compound B. So the statement what is given here, in direct reactions only a few nuclei in the periphery are involved, that is correct, because in that case the interaction time is very small, so it will not get that much time to interact with all the internal as well as surface in nuclei. So it will only interact with the surface nuclei, and after that it will go out. Okay? So this is coming from the direct reaction. Now what will happen for this compound nucleus reaction? So obviously, as whatever the special characteristics was there for direct nuclei, for compound nucleus it will be a little bit different. So for compound reaction, interaction time will be large. Large means I can tell you that it is of the order of, I maybe forgot the number, but it is of the order of 10 to the power minus 19. Okay, as I totally forget the number, so obviously I should not tell that one. But it's obviously large in compared to what? It will be the interaction time will be very large compared to the direct reaction. Okay. So what will be the consequence for the interaction time will be large? The consequence is like A and B. A will interact with B. In whole the B it will interact. Inside the whole B it will interact. because the interaction time is very large, so A will interact with all the nuclei of B, and it will create a transition state, a resonance particle, another particle, which is nothing but the addition of these A and B to. So that means in one case A and B will add up and it will give a new particle, which we can call as like resonance particle, and after this resonance particle, this will be a very unstable particle, so obviously the resonance particle will decay in C and D. So in compound nucleus, the main difference with direct reaction is like that. In compound reaction, there will be a intermediate state. Obviously, there may be some more intermediate state, but at least there will be one intermediate state where A and B will completely get together and it will become a new particle, which we can write it as resonance particle, and that resonance particle, due to the instability, it will decay to C and D. That is the thing. Okay? So in compound reaction, interaction time will be very large, so that it will make a transition state. Transition state means that in between this final and initial and final particle, how many states are there, that is known as transition state. So obviously there will be some transition state and there will be some resonance particle and it will decay to the final state. But for the direct reaction, there will be nothing like that. There will be no transition state, there will be no resonance particle. It will simply come as A plus B going to C plus D. Okay. So if it is like that, then coming to the first option, in compound reaction, an intermediate nuclear state is formed which decay to the final products, as I already told right now. So this is correct one. But obviously it is not always true that one intermediate state. It can be many intermediate states, but at least one intermediate state should be there in compound reaction. Now coming to the third option, nuclear reactions in which only the nucleons at the periphery take part are called the compound reactions. Obviously it is not true, because you can see that compound reaction is that where all the nuclei of the particle B will be participating, but in the direct reaction only the surface nuclei will be participating of B. But as in the option number C, it is saying that only the nucleons at the periphery take part, that in compound reaction, that is not correct. So obviously I know that Professor Paulus have explained that compound nucleus and direct nucleus very clearly, but still if you have some doubt on this, obviously there are so many things in the direct and compound nucleus compound nucleus reaction. So if you want to know more about these two, then I will suggest you to go through this PDF. There is a PDF, this is the link for this PDF. So I think you can get the slide through the Google Drive, and from that Google Drive you can just copy that link and you can just paste it in your Google, in online. Then you can get the slides. These slides, this is like I think 29 pages slide. This slide explicitly explain what is known as compound reaction, what is known as direct reaction. So I can suggest that one to have a better understanding on compound nucleus, compound reaction and direct reaction, if you want to know more. Okay. But till now, whatever I am just telling, that is a very broad sense. In a very broad sense, I am just telling. But obviously, there will be so many nuclear reactions inside that, and there will be so many energy and momentum expression should be there to do all the calculations of compound reaction and direct reaction. But the main thing is that compound reaction, inside the compound reaction, there will be one intermediate state will be there, one resonance particle will be produced, and after that the final state will come. And for direct reaction, there will be nothing like that. There will be no intermediate state, there will be no resonance particle, simply the initial particle was there, and after that the final particle will come. So these are the things. Okay, so Up to that, if you have any doubt, you can ask me, or maybe we can go to this question. Okay. I am audible, I think. Yes. So, question number 8. Till now there is no question, right? Okay, if you have any question also, you can just ask me at the last of the session also, that is also fine. Okay, question number 8. Which of the following is or are a purely electrostatic accelerator? And there are 4 options. Croft and Walton generator, Van de Graaff generator, cyclotron and tandem accelerator. Here also I don't want to explain all the generator, all the accelerator, because obviously sir has already explained very clearly what are these accelerators and what are the working principle, how they are worked as a electrostatic accelerator or magnetic accelerator or something. So I don't want to explain all these things, but I just want to tell you the main feature of these accelerators, so that we have to know so that we can get the answer. Okay. So first is Croft and Walton generator. What does this means actually? This is a generator. Obviously, all the 4 are accelerators. Okay. Accelerator means what? Accelerator means this is a device which accelerates the particles. Particles means charged particles. I mean, most of the accelerator are doing with the charged particle only. So accelerators A, B, C, D, whatever it is given here in the options, they all are built only for the same purpose, that we have to accelerate our charged particle. But how to do that? Obviously, charged particle can be accelerated through the electric field. It can also done by magnetic field as well, with some electric field also. But among these 4, which are purely electrostatic accelerator means the accelerators which are only based on electric field concept. There will be no magnetic field concept. So among these 4, which are the accelerators in such a way where they are only using electric field, they are not using magnetic field at all. This is a question. Now option number A, Croft and Walton generator. So this is a generator which can accelerate the particle only through electric field, only through electrostatic field. So I just want to write only one sentence. Obviously I am not going to explain. There is something. There was some sound came. Okay, there is no message. I'm audible, right? Hello?
Yes, ma'am.
Okay, fine. Yeah, so I'm not going to explain all the working principle of all these generators, but at least only one line I should write for every generator, so that we can understand what will be the answer for this question. So first one, CW generator. CW generator is Cockford and Walton generator. So this is, what is the purpose? And obviously the purpose, we know that it will accelerate the charged particle, that is the purpose. But what is the working principle? The working principle and the motivation of this generator is nothing but, it will increase, basically it will convert a low voltage AC current to very high voltage DC current. AC DC you all know, alternating current, direct current. So CW generator, and also it uses what are the components in that generator? These are nothing but capacitors and diodes. Okay, so this is a generator which is fully made with electric field and capacitor, diode, resistor and all these things. So there will be nothing, there will be no component of magnetic field. So CW generator is purely a electrostatic accelerator. And what is the motivation of this generator? The motivation is it should convert a low voltage AC current to a very high voltage DC current. So the first option is correct. Now coming to Van de Graaff generator. Van de Graaff generator, obviously all of you know from the very beginning. Generator. That is also a purely electrostatic generator, accelerator, and it will do like, it will, here you can see, I think all of you have seen this picture, that there will be a halo, very big halo, circular like thing, metallic thing, and after that there will be a insulated pipe, insulated tube. So this is insulated. And here why it is a that much big circular thing? Because to accumulate the charged particles. Okay, so this is Van de Graaff generator, and obviously this is also based on the totally electrostatic principle. There will be no magnetic field concept here. So Van de Graaff generator is also purely electrostatic accelerator, and it's very widely useful because it make a very high voltage, and I can see that it is of the order of 5 megavolt it can produce. So that means high voltage it will produce, and obviously if high voltage is producing, that means whenever the particle will go through with that high voltage, then that will be accelerated. So obviously Van de Graaff generator is very much useful for our particle accelerator case, but it is totally electrostatic, purely electrostatic. Okay, so that is also correct. Now coming to cyclotron, I am not going to tell right now cyclotron in detail, because in the next question also there will be a cyclotron question. So obviously I will explain that one in detail there. But I can right now tell cyclotron is also an accelerator, but it is the combination of magnetic and electric field. Okay, so this is a combination of magnetic and electric field. So the option will not be the correct one, because they are asking that what will be purely electrostatic. Now coming to tandem accelerator. Tandem accelerator is also a purely electrostatic accelerator. If you want to see the working principle, you can see the Wikipedia, or you can see in the book also, or you can see in the lectures also. But tandem accelerator is not that much effective. Okay, so that's why we can just simply not that giving that much importance here. But yeah, you can also see that tandem accelerator is also a purely electrostatic accelerator. Okay. Maybe we can, okay, at least I did not tell any explanation of these each and every generator and accelerator, but I just told you that what is the motivation of this generator and accelerator and how it is working. Like obviously these A, B and D work in the electric field concept, there will be no magnetic field concept, but for cyclotron there is magnetic field concept. That's it. Okay. Okay. Right. Where is this question? Yeah. Now this is ninth question, and it is based on the cyclotron principle. So actually I wanted to tell you about the working principle of cyclotron, but if you all know about the working principle very clearly, then maybe I can only use the expression to calculate the mathematics. Actually here it is only the mathematics. So if you want me to explain the working principle of cyclotron, and after that we will calculate the mathematics, then also it is fine. Or otherwise, if you tell me that okay, you know the working principle of cyclotron very well, because and I just want to know the mathematics, then obviously I can just write the expression, and after that I can calculate that one. So it's up to you, whatever you want, because it's still, I think, more than half an hour is there. So whatever you want, that only I can do. Like if you want to know the working principle as well as the mathematical expression and the mathematics, that also I can do, or only the mathematical expression, that also I can do. So can anyone tell me like what I can do? Like obviously the mathematics I can obviously do without any explanation, that can also be fine. Or otherwise, if you want to know the working principle of cyclotron and after that the mathematical expression, that is also fine. Because I have one more question at the last, yes. And this is also very similar to the first one. And there is no other question. This is also very similar to the first one. So I mean, last 4 questions are only based on the cyclotron. So okay, I mean, if we know the ninth question very carefully, then only we can know all other questions. There is something in the chat box. Mathematical expression. Okay, very good. So I hope that you all know the working principle very nicely. So that means only the mathematical expression is fine. Okay, so let me write here only the mathematical expression. Let me first read the question. Obviously, a cyclotron has D's with radii 1 meter and uses a magnetic field of 1 Tesla. To accelerate a proton, the frequency of oscillating electric field used should be how much? I mean, it is in unit of megahertz, and you have to write it up to 1 decimal place. So for the cyclotron, what is there in that cyclotron? Maybe simply I'm just writing. It is like that, D1 and D2, and the radius of this D1 and D2 is given here. Radius is given as 1 meter. Okay, radius is given as 1 meter, and magnetic field is given as 1 Tesla. They are asking that what will be the frequency, and the particle is proton. The proton mass is already given. I mean, I know the mass of proton. Now they are asking that what will be the frequency, nu. So to calculate the frequency, what do we need to know? We need to know that there will be like QVB sin theta. QVB sin theta means like Q into V cross V. That is the force due to the magnetic field. Okay. So QVB sin theta, and in that case, if you see the cyclotron principle, then you can see that QVB sin 90. Okay. So it will be simply QVB. It will be simply QVB. So this is the force required, force coming due to the magnetic field, Q into V cross V, Lorentz force, right? So this is equal to A mv square by r, because it is in the circular motion. So magnetic field is only responsible for the circular motion in this case, I mean for the cyclotron case. So obviously we can write qvb equal to mv square by r. Now from that case I can know the value of v. V is simply q r b divided by m. This is velocity of the particle, right? Now time period. Time period is what? If it is a circular motion, then time period will be 2 pi r divided by v, because this periphery, I mean total periphery circumference divided by the velocity. So it will be 2 pi r divided by v. So 2 pi r divided by q r b into m. So it will be 2 pi m divided by qb. Now frequency. Frequency is 1 by t. So it will be qb divided by 2 pi m. This is the expression. Okay. Now as it is already given, what are the things given here? What are the things given here? Radius is given, I mean radius is given, magnetic field is given, and proton is given. Okay. So to calculate the new Q is what? Q is 1.6 into 10 to the power minus 19 coulomb for proton. Then B is 1 Tesla divided by 2 pi into m. M is how much? M is 938 MeV. So it is the mass of the proton is how much in kg? It is 1.67 into 10 to the power minus 31 kg maybe. If I am getting wrong, then you can just, I think 27 or 31, 27 I think. Can anyone tell me what is the mass of the proton in a kg unit? I think 10 to the minus 27. I hope so, you have to check that one, because it's simple, you have to just put the value of mass of proton, and Q is there, B is there, 2 pi is there. So if I just calculate these things, then we can have the value of frequency. Oh, by the way, the frequencies should be in the megahertz. Okay, fine. So it should be something into 10 to the power 6. So we have to write the answer here. So maybe I can calculate here also 1.6 into 10 to the power minus 19. I think I wrote it correctly, 1.67 into the minus 27. Can anyone confirm and check it? Is it correct or not? The mass of the proton in kg unit. 10 to the power minus 27. I hope it's correct. So if it is correct, then it will be like 15.24 into 10 to the power 6 hertz. So it is simply 15.24 megahertz. Just check the mass of the proton in kg unit. If it is correct, then the answer will be 15.24. Okay. Okay. So these are the expressions. These are the main expressions to calculate all the mathematics regarding cyclotron. This is 1, this is 1, and this is 1. Okay, fine. Now maybe we can go to the next question. If you have any doubt, you can obviously ask me. In the above question, cyclotron proton can be accelerated to a maximum kinetic energy of how much MeV? See here, they are asking that what will be the kinetic energy. So for kinetic energy is how? What? Kinetic energy is half mv square. Now we need to know the v at first, and m is already given as mp, right? So to calculate kinetic energy, we need to check the value of v. What will be the value of v here? So v expression is what? Q RB by m. My laptop is T kinetic energy. Kinetic energy of proton is half m v square, and v is, what was the expression of v? Because I have to again go q b r by m. Okay, q b r means this by m. So v square will be q square b square r square by m square, and as t is here, half m q square b square r square by 2m, m square, simply m square. So that will be q square b square r square by 2m. That is the expression for kinetic energy. Now you have to write it, all these things, all the terms in correct unit, and after that you can get the answer. Okay, like in kg, if I want to write, b is in Tesla, so that means it is in SI unit. So 1.6 into 10 to the power minus 19 whole square into 1. Radii was also 1 meter divided by 2 into 1.67 into 10 to the power minus 27 kg. So all the things, whatever the kinetic energy will be there, it will be in SI unit, but you have to convert that one in MeV unit. That's it. Maybe you people can do that, or I think we can go to the next question. Basically this is the simply expression, and we have to just convert the unit, and after that we can get in the MeV unit. That's it. Okay. Okay. So maybe we can come here. A cyclotron has Ds with radii 5 meter and uses a magnetic field of 3 Tesla to oscillate a proton. The frequency of oscillating electric field used should be how much in megahertz unit? So it's exactly similar whatever it was there previously. Nu is 2 pi m. No, nu is nu is qb by 2 pi m. Sorry. Oh. Hello, actually I was disconnected. Share. So it is qb by 2 pi m. So just we have to write the q and all these things, and it is a proton, so obviously 1.6 into 10 to the power minus 19. Then b is 3 10 pi m. Obviously as frequency is independent of radius, so there will be no r term here, so simply it will be 3 divided by 2 pi 1.67 into 10 to the power minus 27. Okay, so this is the frequency for this case. So simply you can calculate that one, 1.6 into 10 to the power minus 19 into 3 divided by 2 into pi into 1.67 into 10 to the power minus 27, and this is 45.7451333 hertz, something like that. So it is like okay, into 10 to the power 6, so 45 megahertz. That's it. Okay, so this is 45 megahertz, the frequency of the particle. Now coming to the last question, maybe. the above question, cyclotron proton can be associated with a maximum kinetic energy of how much? So this is exactly similar like whatever we told, that T, that means the kinetic energy, that will be half mv square. Kinetic energy, like let's say here kinetic energy of proton. Is not getting right properly. Okay, so kinetic energy of proton is like half mv square, and V we can calculate from the expression that V is QBR by M, and then obviously we can do that calculation in terms of MV unit. Obviously we have to think that the unit we are taking, that is should be consistent throughout the calculation. Okay, so this is half mv square, and V is like QBR by M, and M is given as 5 meter I think, so we have to put that value, and B is given as 3 Tesla, then we can get the answer. Maybe I will not do calculate that once the velocity right now, because it's simply a mathematics, so you can do by yourself that one, but I just wanted to know that what will be the expression for that, and what will be, how to calculate the question and how to answer the question. So this is the last question maybe. So if you have any doubt, you can ask me among these 12 questions, anything. If you have any doubt, you can ask me. So maybe I can go through each and every question to do a recap of you. I think first question was P2N or N2P. Then second question was to calculate the Q value. Then the next one was the differential cross-section calculation, and then the next question was electrostatic accelerator. Among these four, which one will be the electrostatic accelerator? Then the next one will be related to the cyclotron mathematics, and then there was 4 questions on cyclotron mathematics. First you have to calculate the frequency, and after that you have to calculate the kinetic energy. That's it. So these are the questions. If you have any doubt, you can ask me. Oh, again I got disconnected. I'm getting disconnected again and again, but yeah, fine. So class, so if you have okay, so if you have any doubt, you can ask me, or otherwise we can stop today's class and we will meet in the next class. In the today's class, any doubt? Anything? Oh, okay. Okay, then bye-bye. Thank you. Good night. Bye-bye.